Okay, so we have a task management project, and we want to add a new feature that introduces due dates for tasks along with automatic reminders. Before jumping into implementation, let's first generate the system.sm file for our project to review the current architecture of our task management solution. After that, we'll ask AI to design a feature and create another SM file representing the architectural changes required to implement this new functionality. To begin, let's set up SpecMind in our project. Now that we've copied the / commands into our project, we can run Claude code. Next, let's run the analyze / command. This command will start the process by invoking the SpecMind analyze command. Let's confirm that we want to run it. The SpecMind analyze command generates a SpecMind /system folder containing a set of JSON files representing the project architecture, built from the abstract syntax tree created by SpecMind. Then, Claude will read all these files to fully understand the project and generate documentation along with diagrams. In addition to the diagrams, it will also create a folder under SpecMind, where all future feature-specific documentation will be stored. Now it's generating the system SM file. Okay, the system file is ready. Let's review it. You can find it under the SpecMind folder. It's a markup file you can review, submit for team review via PR, or open in preview mode using the SpecMind extension for Visual Studio Code, Cursor, or Windsurf. The generated documentation is based directly on your code base. The first diagram you'll see, following the overview section, is the system architecture diagram, which shows the high-level structure of your services, how they interconnect, and how data is stored. We can see a PostgreSQL database for persistent storage and Redis for caching and queuing. You'll also see all services, data storage, external integrations, and communication patterns. Then come the project flows, illustrated with sequence diagrams. For example, create task, get task, update task, delete task, etc. Each service also has its own detailed architecture section. For example, in the API service section, you can explore all methods per layer and how they interact. You can open these diagrams in zoom mode for detailed inspection. Each service section includes its layers, API, service, data, external, etc., and entity relationships with detailed entity diagrams, showing fields, relations, primary keys, constraints, and types. At the end of the document, you'll find a summary of everything. Now, let's go back to Claude and run the design / command, providing a description of the feature we want to build. You can be as detailed as you want. In this case, I'll specify that we want to add due dates to tasks and send automated email reminders with configurable intervals before and after deadlines. When we run this, Claude will first read your system.sm file to understand the current project architecture, then process your feature description, and finally generate a feature-specific SM file. It might also reference your codebase for more detailed insights. After about 5 minutes, the task due date reminder SM file is ready. AI took the necessary time to design the technical details properly. Let's review the generated SM file, located under the features folder created earlier. This feature specification file is written in markup, meaning you can edit it, modify it, and send it to your team for review. If you have the SpecMind extension installed, you can preview it directly. So here, what you will see, typically for feature-specific SM files. First, you will see the overview. Next, you will see the requirements. You will see functional and technical requirements that can later be considered by the AI during the implementation phase, as well as non-functional requirements. Here, in the system architecture in green, you will see the services that will be added as a result of implementing this feature. In orange, you'll see the services that will be affected, meaning something will change there. You will find more information about what's going to be added or updated under the diagram in the Impact section. The same applies to the sequence diagrams. It might create new flows and new sequence diagrams, such as this one, the task due reminder flow. It can also modify existing sequence diagrams. The same goes for the service architecture. As you can see, it will make several changes in our API service. It will add methods in the service layer, add methods in the API layer, and update some existing ones as well. Under the Affected Layers section, you'll find more details about what exactly will be changed. In the entity diagram, you'll also see the updates. In green, you'll notice the entities that will be added. For example, the AI plans to add a reminder log and update the task entity to include reminder intervals, due dates, and other related fields. You can review all these changes in detail here. It even outlines what type of database changes should be made. The same approach applies to all services. You'll also see that it creates an entirely new service called the Reminder Scheduler service. There will also be additional sections like design decisions. For instance, what new technologies might be introduced, how time zones are handled, and how interval configurations are managed. It will also include integration points to show how services will interact with each other. And at the end, you'll find an implementation plan, broken down into phases such as Phase 1 and Phase 2. Ignore the Week 1, Week 2 labels. Those are for human timelines. If you're using AI, these steps might take hours or even minutes instead of weeks. The good news is that you now have full, comprehensive documentation of what's going to be implemented. You can share it with your team, gather reviews and feedback, and only then move forward with implementation. Once you're satisfied with the design, you can proceed with implementation. Go back to Claude and run the implement command. Implement tasks, due dates, and reminders. The system will automatically detect the relevant feature, read the feature-specific SEM file, and begin implementation based on the documentation. Confirm the edits. For demo purposes, we can approve everything automatically, though in practice it's better to review each change. Okay, it's done with the implementation. As you can see, it's now also updating the system file. This ensures that our system SM file is always up to date and aligned with the code. Along with the system SM file, it also creates a system changelog file. After each implementation, it records the actual changes made, so you can always keep track of your system updates. Now, as you can see, it has implemented the new service, updated existing ones, and made all the necessary changes. If we open our system SM file and preview it, we can see that the new service is already there. We have updated flows, we have new flows, and changes reflected in the service diagrams. You'll also notice updates in the entity relationship diagrams. This applies across all services. If you open the system changelog, you'll find the date, a short description of the feature, and details about what was added, modified, and other information related to that feature's implementation.